Lesson 5-1, Monomials. A monomial is a single-term polynomial. Can have more than one variables, can have coefficients. When we're going to simplify these, make sure we understand that anything that has powers means to rewrite the expression without parentheses, and you cannot have negative exponents. So on this first one, we're multiplying the monomial 3x cubed y squared times negative 4x squared y to the fourth, that monomial. Okay, when you multiply monomials, and what this is all showing, I'll try and explain it here, is we multiply the coefficients. So I take 3 times negative 4. Remember, coefficients are what's in front of the variable. So that would be negative 12. And then I'm going to take x to the third times x squared and use the product rule. The product rule says I add exponents on my like basis, so that'd be x to the fifth. And then I want to take y squared times y to the fourth. Same thing there, we're going to add exponents, so that would be y to the sixth. So when I multiply those two monomials, that's what you get. This is a review of the product rule, which we really used on the last problem. But basically it says when I multiply like basis, I add exponents. Okay, so whether the base is a number like it is here, 4 squared times 4 to the ninth, the base stays a 4. You do not multiply 4 times 4. You add the exponents when you multiply, so it'll be 4 to the 11th. When you're multiplying b to the third times b to the fifth, base stays a b, and it becomes b to the eighth. Quotient rule, or quotient of powers, basically does the opposite. When you're multiplying, you add. Here I subtract, and remember this is like 5 to the first, so it's 5 to the 3 minus 1, or 5 squared. If the base is a variable, x to the seventh divided by x to the third, I subtract those exponents and I get x to the fourth. So quotient rule is you subtract exponents. Okay, so we're going to use that here. I have p to the third divided by p to the eighth. I subtract exponents from top to bottom. So it's p to the 3 minus 8 power, which is p to the negative fifth, but we cannot have negative exponents. Okay, remember this is like p to the negative fifth over 1. So what you do is you really move that down, and it becomes p to the fifth on the bottom, and getting rid of everything on top leaves you with a 1 on top. It's not a 0, so it's 1 over p to the fifth, and they're just showing you a check here. When they do this, they're kind of saying p to the third is 3 p's multiplied together, p to the eighth is 8 of them. You know, these 3 cancel with 3 of these, so it's 1 over p to the fifth, which is what they have right there. Okay, this is showing you a reminder what anything to the 0 power is, and we're going to use the quotient rule. For instance, if I have y to the fourth divided by y to the fourth, and I subtract exponents there, I get y to the 0. If you look at method 2 here, they're showing y to the fourth as y multiplied together 4 times right here. Same thing on the bottom, and all those y's cancel out and leaves you with 1 or 1 over 1. So that's kind of proof that y to the 0 is equal to 1, and actually anything to the 0 power is equal to 1, which is what is stated in the box there at the bottom of that page. Some other rules. Okay, we did the product rule and the quotient rule. Now we have power to a power. The book calls it power of a power, but we say power to another power, to an outside power. We multiply exponents. A lot of students get those backwards, but if it's power to an outside power, so here's an example of that. A to the second, outside power of 3, is a to the sixth. Okay, really that comes from the product rule, in that I'm going to take a to the second and multiply it by itself 3 times, which leads you to a to the sixth. But the shortcut is you just multiply exponents. If you have more than one variable inside, you take both the variables to that, and that's what they're doing right here. Okay, if it's power of a quotient, the fraction, and if this exponent is positive, take the top and the bottom to that exponent. So a, take it to the outside power of 3, same thing with b. In this case, it'd be a to the third, b to the third. If it's a negative exponent, and it's a fraction it starts out with, you want to take and change to the reciprocal, okay, and then make the exponent positive in that process. Okay, so if you're looking at this example right here, I'll just do this one for you. I had x over y, outside power of negative 4. Automatically, right away, flip the fraction over, so it's y over x, make it to the positive fourth power, which would be then you use the power, top and bottom, would be y to the fourth over x to the fourth. Always make your exponent positive if it starts out negative exponent in a fraction. Okay, we got 4 examples here to look at. Real simple one to start out with. That's just the power to a power rule, in that we multiply exponents. Okay, power to an outside power, so it's a to the 18th power. This one over here, now it has a coefficient. You need to take that coefficient to the outside power. I do not multiply negative 2 times 5 because negative 2 is not an exponent. It is a coefficient. Okay, and that would be, and put it in parentheses, that would be negative 32. And now you do the power to a power here with p to the third outside power of 5, which is what they're showing you right here. So that'd be p to the 15th. Same thing, you have s squared inside, and you take it to the 5th power, which would be s to the 10th. So that's what that answer is for that particular problem. Down here, you got a fraction or a quotient. Outside power is positive to start with, which means I take the negative 3x to the 4th power. So notice they put negative 3 inside parentheses there. Okay, so I need to do negative 3 to the 4th power, and then also the x to the 4th power, and then y to the 4th on the bottom. If it's a number to a power, though, we actually need to do it, or we can simplify it, and that, notice you put it in parentheses and make sure the parentheses, that would be a positive 81, and then you'd have x to the 4th, and on top over y to the 4th, which is what they got right there. Okay, remember to put it in parentheses when you're raising it to a power. This one that starts out negative, if you have a over 4 and it starts out negative exponent right away, flip it over, make it 4 over a, and make the power positive 3, because it means the same thing, and you always want to deal with positive exponents. So then on top I need to do 4 to the 3rd power. On the bottom I need to do a to the 3rd power. 4 to the 3rd power is 4 times 4 times 4, or 64, over a to the 3rd power. Okay, this one, the rules stay the same. They just throw a variable in the exponents. Notice you have negative 2 and then x to the 3n power. All the rules stay the same. Okay, so if you have that negative 2x and the 3n power on that, okay, and actually we have a fraction here, and then it's x to the 2n and y to the 3rd. Okay, outside power is 4. Nothing has changed. Okay, we're still going to take the coefficient on top, negative 2, raise it to the 4th power, and then you need to do x to the 3n raised to the 4th power. On the bottom, we're going to do x to the 2n raised to the 4th power, and y to the 3rd raised to the 4th power. And if we do that, on top, negative 2 in parentheses to the 4th power is positive 16. Here, power to a power, I multiply exponents, so it's x to the 12n power. Okay, it's just 3n times 4, just you have a variable involved. On the bottom, same thing here, power to a power, so that's going to be x to the 8n. Here I don't have a variable with my y's, power to a power would be y to the 12th. Now, because it's multiplication here and here, we can use the quotient rule to simplify the x to the 12n over x to the 8n. We subtract exponents from top to bottom, and notice they are like terms. Okay, so on top I'm still going to have 16, and then 12n minus 8n is x to the 4n, or it's 4n power, and then I'm going to have y to the 12th on the bottom. And that's as far as you can go, which is the answer they had right there. Okay, and they're just showing you another method over there. Okay, some scientific notation stuff here at the end of the lesson. Scientific notation is you usually have a number between 1 and 10, and it's raised, or that needs to be 1 to 10, and then you have a 10 to the power on it. If you have really big numbers, okay, meaning a lot bigger than 1, the exponent's going to be positive. If you have really small numbers, the exponent is going to be negative. So here, we're going to move the decimal over, so if I start out with 6380000, here's my decimal point. I need to move it over, drop off all my zeros, and make it be 6.38 times 10, because this number's got to be between 1 and 10, and then how many places you moved it. This is a big number, bigger than 1, quite a bit bigger than 1, so it's going to be a positive exponent how many places you moved it, which is 6, so it's 6.38 times 10 to the 6th. Okay, I don't really do it the way they did it there. I just think of really big or really small. This one is a decimal between 0 and 1. You have 0.000047. So here's where my decimal point starts out. I want to move it over and make it 4.7 times 10 to the what? Well, if this is a small decimal between 0 and 1, the exponent must be negative, and then how many places you moved it, which is negative 5. Okay, look at some operations here, multiplying numbers in scientific notation. When you multiply two numbers in scientific notation, rule's pretty simple. You multiply the numbers in front, or what I call the coefficients of the times 10 to the power, so 4 times 2, which is 8, and then you multiply 10 to the 5th, or whatever the power is on 10 there, with that one, which is what they're showing right there. Product rule says add exponents, so it's 10 to the 12th, so that first one would be 8 times 10 to the 12th power. Just make sure that the final answer, that number out in front, is between 1 and 10, which it is in this case. Another example down here, this one just involves a negative exponent. We still want to multiply 2.7 times 3, which is what they're showing there, which gives you 8.1. Okay, and then multiply your exponents here. Okay, you don't have to make them positive, just because you can have negative exponents in scientific notation, but you just add exponents. Negative 2 plus 6, product rule, would be to the 4th power. So it's 8.1 times 10 to the 4th. Okay, and then we end with a division problem here, dividing numbers in scientific notation, which is kind of just the opposite of multiplying them. You're going to take and divide 4 by 3, which is what they're doing right here. Now they did round this off, but they got 1.33. They got 1.33. Rounded it off to 2 decimal places, and then right here, they subtract exponents, top to bottom, because we're dividing now, so 16 minus 8 is 10 to the 8th, so it's approximately 1.33 times 10 to the 8th power.